Now being recorded. Okay, good morning. Okay, till now we were discussing about many type of suspensions, right? Now the last topic is hydrogen suspension or the hydrogen interconnected suspension. In that, the main thing is hydro-pneumatic suspension. This is the last topic. അപ്പോൾ ഫോർത്ത് മോഡ്യൂൾ ഇതോടെ നമ്മുടെ കഴിയാണ്. ഈ ഒരു ചെറിയൊരു ടോപ്പിക്കും കൂടെ വരുന്നുള്ളൂ, ഹൈഡ്രോ ന്യൂമാറ്റിക് സസ്പെൻഷൻ. അപ്പം ഹൈഡ്രോ ന്യൂമാറ്റിക് സസ്പെൻഷൻ അപ്പം എന്തായിരിക്കും? ബൈ ദ നെയിം ഇറ്റ് സെൽഫ് എന്താണ്? ഇറ്റ് ഹാസ് ടു കോമ്പണൻസ്, ഹൈഡ്രോ ആൻഡ് ന്യൂമാറ്റിക്, hydraulic system and pneumatic system. So here two types of systems are using. That is, first one is hydraulic system and then pneumatic system. So there should be some positive aspect or some advantages over other type of suspension. Why we are using this type of suspension? Because both that hydraulic system and also pneumatic system has its own advantage. So regarding the hydraulic system, it mainly uses the torque multiplication, and using that the torque is multiplied, and also there is no use of mechanical parts or mechanical linkages, mechanical gears or levers, etc. So as we have already seen in the steering mechanisms, while using hydraulic system we can avoid many vibrations, shocks, etc. Right? So in this case also, by using hydraulic part or hydraulic systems, we can achieve torque multiplication also, the need of or we can prevent the need of mechanical gears or levers. Next, the pneumatic system. Pneumatic system, it is mainly due to the fact that the gas, there we are using gases, right? And the gases, what is the property? Main property is that it is incompressible. It is incompressible. So while using this particular gas, any gas in the system, that is by utilizing the pneumatic power, we can avoid the damage due to shock loads. So the impact loads or shock loads can be prevented by using the gases, because it is much compressible. Due to the compressible nature, incompressible എന്നാണോ നേരത്തെ പറഞ്ഞത്? Anyway, compressible nature കാരണം എന്താണ്? It can prevent the shock damage. ഇതാണ് ഹൈഡ്രോളിക് or hydro-pneumatic suspension. ഇനിയിപ്പോൾ എന്താണ് hydro-pneumatic suspension? What are the components or the working principle behind the hydro-pneumatic suspension? So a typical structure is shown here. Here this is the spring unit. This is the spring unit or the unit which provides the spring mechanism. Spring mechanism കൊടുക്കുന്നത് ഈ ടൈപ്പ് യൂണിറ്റിൽ നിന്നാണ് കൊടുക്കുന്നത്. ഓക്കെ, ഇനി അവിടെ എന്തൊക്കെയാണ് കാണുന്നത് നോക്കാം. There you can see a spherical part, and okay, spherical part, and it is containing nitrogen gas. Here you can see a diaphragm, flexible diaphragm, mainly made up of butyl rubber. Then here, this is the displacer chamber. This is named as displacer chamber, that we will be discussing later. And here you can see a piston, crown piston or conical piston. Here also there is a diaphragm, flexible diaphragm, mainly made of nylon reinforced rubber. Now we can see how is it's working. So here in this suspension, the spring unit consists of a nitrogen-filled spherical spring chamber. This is that nitrogen-filled spherical chamber, which is welded to double conical shaped displacement chamber. This is the displacement chamber, and both are welded together. Now, a hydraulic damper which separates both the spherical spring and displacer chamber. Now, a hydraulic damper, hydraulic damper is used to separate both these parts, that is the spherical spring chamber and also the displacer chamber. And this particular damper is used to control the fluid of or fluid flow, that is whether the fluid here in this spherical spring chamber, here it is nitrogen gas and it is sealed using this particular diaphragm, which separates the fluid contained in this chamber, that particular fluid, and the control of that fluid is made by the hydraulic damper. Now, the displacer chamber is closed at the lower end by a load absorbing. Here, the displacer chamber is closed at the lower end by a load absorbing nylon reinforced rubber diaphragm. Nylon reinforced, okay, nylon reinforced rubber diaphragm that rolls between the conical piston and tapered displacer chamber. That is conical. This is the conical piston and this is the tapered displacer chamber. Tapered displacer chamber. It will be rolling over. That is this particular what do you call diaphragm will be rolling over these two components. Now, butyl rubber diaphragm. Here you can see this. The butyl rubber diaphragm within the spherical spring chamber separates the sphere into a nitrogen charged upper region. Here is a nitrogen charged upper region. So, this particular diaphragm, which is made up of butyl rubber, this separates the nitrogen gas or nitrogen filled chamber into a sorry, and it is sealed for life, and lower region is filled with the fluid, and this lower region it is fully filled with a fluid. Now, initially the fluid is pumped into the displacer chamber until it reaches the nitrogen charging pressure. So, at the initial stage, what happens is the fluid present here, it is filled or pumped to the displacer chamber from a reservoir tank. So, from the reservoir, this particular fluid is it will be having some certain qualities or composition that will be pumped to the displacer chamber at a particular pressure, so that it will be maintained. The pressure is maintained for the adequate purpose. Now, the separator diaphragm is flexible valve, is a flexible valve to keep the gas and fluid part. So this is the separator diaphragm, and this separator diaphragm, which is flexible, and it will keep the gas and fluid part. So now the fluid, regarding the fluid, it is mainly 50% industrial alcohol, industrial alcohol, alcohol 50%, and a small percentage of anti-corrosion additive plus some anti-corrosion additives. So we are adding some additives also for preventing the corrosion to the components. Anti-corrosion additives. So this is the mixture. This particular mixture is the fluid. So in this condition, the car's body is ground, car body to the ground height is checked. Now the height of the body or the car body is checked. So this is the basic construction features of a hydropneumatic suspension. Now we move to hydropneumatic automatic height correction suspension. This is mainly working on this particular principle or this components, using these components. So we will be telling about this components, that is spherical chamber, displacer chamber, etc. So these terminologies are applicable to that particular suspension also. This is the general layout of a hydropneumatic automatic height correction suspension. Automatic height correction suspension. What do you mean by that? That is, for certain vehicles, we can see the height correction depending upon the load or the road conditions. The height is adjusted automatically. So the height correction is done, and it is done using this principle, that is hydropneumatic principle, using that chamber and all. So this is the general layout. കണ്ടു ഞെട്ടണ്ട. അപ്പോൾ ഈ ഫിഗറൊക്കെ എന്തായാലും പഠിച്ചേ പറ്റുള്ളൂ, വേറെ നിവർത്തിയില്ല. വരയ്ക്കുന്നതല്ലേ, അത് ഒന്നിലധികം തവണ നമ്മൾ പേപ്പറിൽ വരയ്ക്കുമ്പോൾ അത് നമ്മുടെ മനസ്സിൽ ഇങ്ങനെ വരും, മനസ്സിലായില്ലേ? അപ്പോൾ അത് പഠിക്കുക, വേറെ നിവർത്തിയില്ല. അപ്പോ ഇതില് ഹൈഡ്രോനമാറ്റിക് ഓട്ടോമാറ്റിക് ഹൈറ്റ് കറക്ഷൻ സസ്പെൻഷൻ, ഇതിൽ മെയിൻ ആയിട്ട് വി ആർ ഹാവിംഗ് 4 കോമ്പണൻസ്. 4 കോമ്പണൻസ് ആണ് ഇതിനകത്ത് വരുന്നത്. അതായത് ഫസ്റ്റ് വൺ ഇസ് സ്പ്രിംഗ് യൂണിറ്റ്. സ്പ്രിംഗ് യൂണിറ്റ് വരുന്നുണ്ട്. സ്പ്രിംഗ് യൂണിറ്റ് മെയിൻലി ഡീൽസ് വിത്ത് ദ സ്പ്രിംഗ് മെക്കാനിസം. നെക്സ്റ്റ് പമ്പ് അക്യുമുലേറ്റർ. Then pressure regulator. And last, height correction valve. Height correction valve. These are the 4 components used in hydropneumatic automatic height correction suspension. Okay. So regarding the construction details, here any automobiles or any vehicle incorporating this type of suspension, the front suspension may be a MacPherson strut or transverse double wishbone arrangement. And the rear suspension will be trailing arm type suspension. Trailing arm type suspension. The front and rear anti-roll bars are used to increase the body roll stiffness. So anti-roll bars, we are already studied about the anti-roll bars. What is the purpose of that and all. So here also we are utilizing the anti-roll bars in the front and rear portion to increase the body roll stiffness. Roll stiffness increase ചെയ്യാൻ വേണ്ടി നമ്മൾ ഈ പറഞ്ഞ anti-roll bars ഉപയോഗിക്കും. Now they are also used to actuate the front and rear height correction valves. Height correction valves. Height correction valves എന്ന് പറയുമ്പോൾ നേരത്തെ പറഞ്ഞ പോലെ ഹൈറ്റിനെ കറക്റ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട്. അപ്പൊ അതായത് ഇപ്പൊ നമ്മുടെ ആവശ്യം അനുസരിച്ച് അതായത് ഇപ്പൊ ലോഡ് കൂടുന്നതനുസരിച്ച് ഇപ്പൊ ലോഡ് കൂടുകയാണെങ്കിൽ കുറച്ചൊന്ന് താഴും ബോഡി. അപ്പൊ അതിനനുസരിച്ച് അങ്ങനെ അതുപോലുള്ള ഹൈറ്റ് കറക്ഷൻസ് പോസിബിൾ ആവുന്നത് യൂസിങ് valves, certain valves operated using the hydropneumatic principle. അപ്പോൾ ഈ ഹൈഡ്രോന്യൂമാറ്റിക് എന്താ പറയാ മെക്കാനിസം ഉപയോഗിച്ച് എന്താണ് ഇതിനെ നമുക്ക് മെയിൻറ്റെയിൻ ചെയ്യാം. or using the pressure or the force produced by the hydropneumatic suspension, we are adjusting or we are correcting the height. Now one by one, first is the spring unit. So what all things come under a spring unit? So spring unit mainly consists of these things. This particular thing is coming under the spring unit. So just reminding that is a steel spherical canister or cylindrical shaped container. You can see here. Contains a rubber diaphragm that separates the nitrogen spring medium from the displacement fluid. The nitrogen container, that is here you can see the nitrogen is contained here in the spherical chamber, and it is separated from the fluid in the displacer chamber by a separator diaphragm made up of butyl rubber. Then a steel cylinder and piston which relays the suspension's vertical deflection movement to the diaphragm by displacing the fluid. So by displacing the fluid, that means here you can see fluid is present here, and by displacing the fluid, that is when we are having a hump or any pit hole. While having a hump, what happens is this will move upward, or when you're having a sudden shock, it will move upwards. That will create a pressure over here, and that may move or pushes the fluid towards here and will compress here. And also after that, it will while having a straight rod or the load is removed, what happens is this pressure will be higher, so it will push back and it will go down. So there will be a smooth flow or smooth motion or smooth springing action. Likewise happens here. The piston is pushed inwards so that it displaces the fluid from the cylinder to the sphere when the vehicle wheel meets a hump on the road. So while meeting with a hump, what happens is it will pushes the piston, that conical piston, and it will create the pressure, and it will push the it will displace the fluid from the cylinder to the sphere. Now the flexible rubber diaphragm compresses the nitrogen gas into a small space. So here that will create, or it will compress the nitrogen gas present over here, and it may create a high pressure in this spherical chamber. If the wheel suddenly goes into a pothole, നേരെ തിരിച്ച് ഹമ്പിന് പകരം പോർട്ട് ഹോളിലേക്കാണ് പോകുന്നതെങ്കിൽ വാട്ട് ഹാപ്പൻസ്? Then the pressurized gas expands. So the gas which is pressurized, that is the nitrogen gas, that will expand, and so the fluid will be compressed or displaced backward. The gas is compressed or expanded relative to the initial charge pressure by this method of changing the volume of fluid entering the sphere. അതാണ് ഈ പറഞ്ഞിരിക്കുന്നത്. അതായത് എന്താണ്? Depending on the nature or the pressure, it will be expanding or compressing. Now the property, the resilience property of the gas, resilience. Property resilience, due to which the gas protects the body structure from shock. Due to this, the gas is prevented or protected, or the components are protected from the shock loads. അതായത് എന്താണ് റെസിലിയൻസ്? മെയിൻലി ബേസിക്കലി ഇപ്പം പറയുകയാണെങ്കിൽ അതിന്റെ എന്താണ് എബിലിറ്റി ടു റീസ്റ്റോർ ടു ഒറിജിനൽ ഷേപ്പ് ആൻഡ് സൈസ് അല്ലെ? മെയിൻലി ഡ്യൂ ടു എന്താ compressive strength or compressive force. Then body is given a compressive stress. What happens is there will be a displacement or deformation, and the tendency or the ability to regain the original shape after the unloading. So these are all about the spring unit. Next, these two, that is pump accumulator and pressure regulator. So the initial fluid pressure source comes from a hydraulic pump. You can see certain pumps. So using the pump, we are giving an initial pressure for the fluid. So the fluid should have some initial power or initial pressure that will be maintained by the hydraulic pump, and it is able to provide a continuous flow of the fluid at a predetermined pressure. So that will help in maintaining a continuous flow of the fluid. Here, the spherical shaped accumulator is fed by the pump. Now, using this pump, the accumulator present in the spherical shape, it is filled with the fluid. Then the accumulator uses nitrogen gas as the spring media and the rubber diaphragm to accommodate the volume of stored fuel. That is already discussed. The highly pressurized fluid is stored in the accumulator. It delivers the fluid to the system in the event of sudden demand. So, as the name suggests, the accumulator or the fluid present in the or stored in the accumulator will be utilized when there is a demand. That is a sudden demand for either in the case of a hump or a pothole, whichever may be, the fluid present in the accumulator is used to give pressure or take the pressure. Now it also allows the pump to idle and hence eliminate the repeated outing in and out. So it helps to allow the pump to become idle. Full time working alla idle avanum help cheyyunnunde. So which may prevents the or eliminates the repeated action of going in and out. The pressure is generated to return the fluid to the reservoir through the pressure regulator. So using a pressure regulator and using the pressure regulator which monitors the pressure whether it is a maximum pressure or a minimum pressure, standard pressure. If it is achieved, then the pump will be inactive, or it will work according to the specified pressure. So the pressure regulator and accumulator unit mainly controls three factors. Three factors will be controlled. First one, the minimum pressure. First one is the minimum pressure. Minimum pressure. Minimum pressure necessary for the operation of the system. Next, maximum pressure. Maximum pressure. Maximum pressure needed to charge the accumulator. Maximum pressure to charge the accumulator. Charge the accumulator. And third is the maximum pressure delivered by the pump. Maximum pressure delivered. So these three are the controlling factors. First is the minimum pressure necessary for the operation of the system. Then maximum pressure needed to charge the accumulator. And finally, the maximum pressure delivered by the pump. Now, regarding the maximum pressure, there are two values. That is, here we can write pump cut-in pressure. Pump cut-in pressure. Cut-in pressure. It is about 140 to 150 bar. 150 bar. And pump cut-out pressure. Pump cut-out pressure. It is about 165 to 175 bar. Okay, so these are the pressure levels. That is 140 to 150 bar is the cut-in pressure, and cut-out pressure is 165 to 175 bar. And these are all about the pump accumulator and pump pressure regulator. Last is the height correction valve. Regarding the height correction valve, okay. See, if the vehicle weight, in case of the vehicle weight due to load, is increased, then it will lower the vehicle body. This mechanism is provided by the this particular valve, that is height correction valve. It is done by changing the volume of incompressible fluid between the sphere diaphragm and the piston. Automatic height correction. That is using this or displacement of the fluid, we can correct the height, or the height correction is done. Similarly, in the case of the that of the suspension, the height correction also is made possible by the displacement of the fluid or the fluid flow, and it causes the suspension arms to deflect and at the same time rotate the anti-roll bar. So while moving the body up or down, and it causes the suspension arms to deflect, suspension arms in the vehicle to deflect, and at the same time it will rotate the anti-roll bars. So earlier we talked about the anti-roll bars. So we are using or utilizing the anti-roll bars also in this type of suspension. And the angular rotation of the anti-roll bar is noted. It is a measure of suspension vertical deflection related to the vehicle's normal static height. So the rotation rotation made by the anti-roll bar is noted, which is a measure of suspension's vertical deflection. So this movement is transferred to height correction valve through the torsional control rod, which is clamped to the anti-roll bar. So here, this particular movement, that is the vertical deflection, and this is transferred to the height correction valve, or given as an input to the valve, height correction valve, through what, a torsional control rod, which is clamped to the anti-roll bar, and using this input, the valve will determine how much fluid is to be displaced, or in which direction to be given, and depending on that, the height is corrected. Now a delayed response is made to the correction valve to avoid the continuous height correction every time when the wheels roll over a dip in the rod. That means the response given to the valve will be a delayed type. That means there will be no quick response. Otherwise, even a minute disturbances occurs. What happens is the height will be continuously changing. That may cause even discomfort to the passengers or the driver. So, in order to prevent that or optimize the suspension, a delayed type of response is made to the valve. So hence the spring unit is not being charged or on bump, discharge on rebound, etc. So after the height correction will be attained only after a small time pause. That means it is having a delay. Now we were discussing on automatic height correction suspension. Here also we have a alternate solution or a manual input also for the height correction. That means we have the possibility to change the height as a manual input also. So there we are using a manual control lever inside the car or whatever may be. So a manual control lever is used, and this particular lever is connected by actuating rods to the front and rear height correction units, and this lever is connected to the actuators at both sides, that is front end and also the rear end. Now there are three positions, that is the three positions available. First is normal, next high or low, then two position. These three positions are available. First, normal means standard operating position. This is the standard operating position. Then high or low, that means extreme positions, whether it is high or low. And two position, it is the intermediate between normal and high. These three positions are available. Now ഇനി ഫോർത്ത് മോഡ്യൂളിന്റെ ക്ലൈമാക്സിലേക്ക് എത്താണ്. ഇനിയും വേറൊന്നുമല്ല, ഇതിന്റെ ഈ പറഞ്ഞ suspension advantages and disadvantages. What are the main advantages and disadvantages? First, advantages. Regarding the advantages, what all things comes under the advantages of the hydro-pneumatic suspension? First one, it offers superior ride quality over all the surfaces. Superior ride quality. It will have a superior or good quality ride. Then it has self-leveling and driver variable ride height facility. Self-leveling, self-at level ചെയ്യുന്നു, അതുപോലെ driver variable ride height facility അതൊക്കെ മെയിൻറ്റെയിൻ ചെയ്തു പോകുന്നു. Next, pneumatic systems are used in this. We already said that both components, hydraulic and pneumatic components are there. So, due to the usage of pneumatic systems, the gas is incompressible and which may cause less damage to the shock. And this type of suspension is widely used on modern tanks and large military vehicles. So we can see for the military purpose and all, we are utilizing this type of hydro-pneumatic suspension. Also in Mercedes-Benz car, Hyundai Ion and all for luxury cars. Paisa ulla vaangiyadi alle. Appam അതേപോലത്തെ വണ്ടികളിലൊക്കെ we are using hydro-pneumatic suspension. Next, it is compact suspension design. It's having a compact suspension design and high durability. High durability ആയിരിക്കും, അതേപോലെ തന്നെ compact ആയിരിക്കും. ഇങ്ങനെയൊക്കെയുള്ള കാര്യങ്ങളാണ്. These are the main advantages. Now regarding the disadvantages. ഏത് കാര്യത്തിനും ഒരു അഡ്വാൻറ്റേജ് പോലെ തന്നെ ഡിസഡ്വാൻറ്റേജ് ഉണ്ടാവും അല്ലേ? So first one is that it requires the trained mechanic for servicing. So there should be a trained mechanic for servicing this type of suspension, because there are a lot of components connected with this system. So it usually requires a proper trained staff. Next, it is very expensive to repair or replace in case of poorly maintenance or poor maintenance. But poor at maintenance cheyanengil endaയിരിക്കും സംഭവിക്കുക? നല്ല എക്സ്പെൻസ് വരും അല്ലേ ഈ സാധനമൊക്കെ നന്നാക്കി എടുക്കണമെങ്കിൽ. Next, the system also causes the failure of suspension completely. അതായത് ഇപ്പൊ എന്തെങ്കിലും ഒരു ഫെയിലിയർ വരുവാണെങ്കിൽ ഈ സസ്പെൻഷൻ ഫുള്ളോടെ എന്താവും? ഫെയിൽ ആവും. അപ്പൊ ഇതൊക്കെയാണ് മെയിൻ ആയിട്ട് വരുന്ന ഡിസഡ്വാൻറ്റേജസ്, മെയിൻലി ഡ്യൂ ടു ഇറ്റ്സ് കോംപ്ലക്സ് നേച്ചർ. ഈ ഫിഗർ കാണുമ്പോൾ തന്നെ അറിയാം ഒരുമാതിരി വല്ലാത്ത അവസ്ഥയിലായിരിക്കുന്നത്. അപ്പം ഇതിന്റെ കോംപ്ലക്സ് നേച്ചർ കാരണം തന്നെ ഇപ്പൊ ഇതിനകത്ത് ഏതെങ്കിലും ഒരു പാർട്ടിനുള്ള ഫെയിലിയർ വന്നു കഴിഞ്ഞാൽ തന്നെ എന്താണ്, ഇപ്പം ആസ് ദ നമ്പർ ഓഫ് കോമ്പണൻസ് ഇൻക്രീസസ് ചാൻസ് ഓഫ് ഫെയിലിയർ ഓൾസോ ഇൻക്രീസസ്, അങ്ങനെയല്ലേ നമ്മൾ പഠിക്കുന്നത്? അപ്പോൾ അതേപോലെ സംഭവിക്കുന്നു. അപ്പൊ അതോടെ നമ്മുടെ 4th മോഡ്യൂൾ ഇവിടെ കഴിഞ്ഞിരിക്കുന്നു, ഈ ക്ലാസ് കഴിഞ്ഞിരിക്കുന്നു. നിങ്ങളുടെ അറ്റൻഡൻസ് ഇതിനകത്ത് ഇതിനകത്ത് ഇടുന്നതിലും ഭേദം ഒരു കാര്യം ചെയ്യാം, നിങ്ങൾ പറയുന്നതായിരിക്കും നല്ലത്. കാരണം എന്ന് വെച്ചാല് ഇല്ല ഞാൻ തപ്പിപ്പിടിക്കണേ കുറച്ച് പാടാം. എനിക്ക് ഒരു മിനിറ്റ്.